This is the solution to example problem number 2, adding vectors by components. So here's the problem. Using the method of components, add up the following vectors. Use the angles that are shown. Do not use any complementary angles. Now, if you don't have any restrictions about complementary angles, then you can find complementary angles and work this problem any way you want. The first thing I'm doing whenever I get a problem like this is I have to put the tails of all the vectors together in the center. And there's a reason for that that'll show up more obviously later on. When we do free body diagrams, we'll look at other vector components. But that's the basic ideas. First thing I got to do is draw the vectors with all the tails all together. It's a three-step process. Step number 1, deconstruct the vectors into horizontal and vertical components. Step number 2, combine the components that point in the same direction, and I'll combine them into an Rx and an Ry, and then I'll construct the resultant. So 3 steps all the time. First thing I'm going to do is I want to identify what's positive. And what's a positive is anything going to the right, anything going up. I can make this anything I want to. But for right now, I'm just going to choose to make it look like math class. To the right is positive and up is positive. Alright, so let's get busy. Breaking this up into components, I have a horizontal component and I have a vertical component. The horizontal component is the side adjacent to the angle. So adjacent, I'm going to use the cosine function because that's adjacent over hypotenuse. So I can tell if they're added because they're connected tip to tail, and the adjacent side is going to use the cosine function. So the hypotenuse times the cosine of 64. So 8 Tesla times cosine 64. The other side, that's the R8 in the y direction, well, that's opposite 64, so I'm going to use the sine function. Hypotenuse times the sine of the angle is going to give me R8 in the y direction. So 8t sine, or 8 Tesla, sine 64 degrees. Now I've got the other hypotenuse to deal with, the 4 Tesla, the 4t. So I'm going to go down first, and then I'll go over. So I can circle the angle that I've drawn here. And going down, I know that the side that's going vertically downwards is adjacent to 48. Since it's adjacent to 48, that's the cosine function. You can also see from a little circle that popped up there that they're connected tip to tail, which means they added. So they're adding together. You have to follow the rules. The components have to add up to give you the final vector. Alright, so back to the vertical side, the 4y is equal to 4t cosine 48 degrees. So that's the hypotenuse times cosine function because it's adjacent. Cosine is equal to adjacent over hypotenuse. Now notice something different about this. In the y direction, R8, the 8 Tesla, it used the sine function because vertically that was opposite of the angle. But for R4, and that's the 4 Tesla, to go vertically, this time it was the cosine function. And that's because the line that I'm interested in was adjacent to the 48 degrees. So don't memorize something like up is always sine and horizontal is always cosine, or vice versa. That's not always true. Just use the rules of trig to figure out if you have to use the sine function or the cosine function. Okay, so now we can move on a little bit quicker. In the x direction, it's opposite the angle, so that's going to be 4t sine 48. So at this point, I've done part 1. I've deconstructed the vectors into their components, and I've been able to describe their lengths. Now let's look at just combining the components in one direction. So I'm going to pick the horizontal direction. By doing that, I'm going to eliminate the vertical direction just to get rid of some of the confusion. So in this case, the answer in the x direction is equal to 8t cosine 64 plus 4t sine 48. Now these two go in the same direction, that's why they're added together like that. And they're both going in what I'm assuming to be the positive direction. When I get my answer, I get a positive answer of 6.479548476 Tesla. And because that's positive, and I've defined positive as going to the right, then my answer is also going to go to the right. So you've got to match it up to figure out which direction it's going to go. If the answer came out negative, say negative 6.47, then it would go to the left, because that's the opposite of positive. Okay, so now let's look at the vertical numbers. The answer, let's see, let me put up my numbers here from earlier. Ry, that's the vertical component of the answer. That's going to equal 8t sine 64 plus 4t cosine 48. But 4t cosine 48 this time is going to be a negative. And that's because 4t is pointing downwards, which is opposite of the 8t direction. Since they're in opposite directions, that's what the negative sign is going to indicate for us, that it's the opposite of positive. So 18 sine 64 plus the opposite, 4t cosine 48. That's what the negative sign is. When I do the math, I end up getting a positive answer, And that means that because it's a positive answer, the positive direction is up. The arrow will also go up. If the answer came out negative, the arrow would go downwards. So now I have all the pieces I need to finish and find the final answer. So I'm done part 2. Part 3, construct the resultant. The two red vectors are the components of the resultant. So I'm going to start with the horizontal component and the vertical component. So I just connected them tip to tail because that's what components do. They have to connect tip to tail. And then I'll draw the resultant, which goes at an angle. Now that I have this, I'm going to find the magnitude of that resultant, and I'm going to find the angle, magnitude and direction of the answer. So to find the angle, in this case I'm going to use the tangent function, the inverse tangent, opposite side over adjacent side. So that's going to be the 4.51 on the top and the inverse tangent of 4.51 divided by 6.48. And that gives me the angle of 55.1 degrees. So that's the direction. Now to find the magnitude, I'm going to use Pythagorean's theorem. A squared plus b squared equals c squared. So the magnitude of r is equal to the square root of r x squared plus ry squared. Putting in my numbers from above, I get the magnitude to be 7.90 Tesla. So the answer has magnitude and direction of 7.9 Tesla and 55.1 degrees, and I've done all 3 parts at this point. Now let's look at what it's going to look like on your paper. So your paper is going to be filled with a lot of stuff. First off, draw big. You can see that my picture is about a third of the page at the top of the page. It's a big drawing because you're going to write a lot of stuff on the side to communicate to everyone else what you're doing. So make sure you draw big. I've assumed a positive direction up there, and I've got everything written out. And if you actually look at the whole paper, it takes up literally the whole paper to find the answer, 7.9 Tesla and 55.1 degrees. So this is what my sheet of paper looks like when I'm done. Lots of space. Don't try to conserve space. Expand it out. The space is great for seeing everything and showing all of your work.